I would like now to welcome all the speakers to the stage, the speakers of this second part of this session. We'll need this. And we still have some time before we need to rush into the bus to have some discussion. Lucas?
I had a question for Lisa on the phage therapy. I'm curious, when it comes to applying the phage therapy in other countries, what kind of blockages do you have from local health authorities to taking on that kind of thing? Because obviously vaccinations are problematic to someone to get registered. So how do governments, say in Southeast Asia, look at phages?
In Southeast Asia, I'm not quite sure, but certainly in the US, it's FDA approved for listeria, to control listeria in food, human food consumption. It's also got GRAS status. And in the US, there's also a product, and I can't remember the name of the company, unfortunately, but they do use phage therapy to spray onto crops such as tomatoes and peppers. So they've obviously got that through regulatory system somehow, but I'm not entirely sure. In Australia, it's like everywhere else. It's really difficult.
You did it in Vietnam. How did you get that through?
In Vietnam, it was all done in a laboratory, so that's not a problem at all. I mean, we can do everything at lab level and keep it all contained, so that's not a problem. So all the in vivo trials have been done in the lab. Our next step is to look at doing full-scale trials outside, and we have to look into how we can go about that. But I think in Southeast Asia it'll be a lot easier than certainly Europe, Australia and the US. Mm-hmm. I hope.
Thank you. Anwar, you had a question?
My question is for Lisa, just curious. We know that Dr. Leitner, 2013, make a press release about the EMS cause. Cause is Vibrio parahelminthecus, which is infected by a virus, and the Vibrio secrete the secretion toxin, right? My question is the virus is Paga virus, phage virus, or what? Because if we, like you say, we can therapy with Paga. If we put Paga therapy in our pond, and the Vibrio can be defense and release the toxin, I think it's more dangerous that we not apply that. Thank you.
That's a difficult question, because the Vibrio parahemolyticus, in my experience, that is associated with EMS, there's several strain variations. There's several variations in the virulence of those strains, and there's still a lot of work to be done. And I'm definitely not the expert to talk about virulence, toxin release and things like that. In my history and in my experience, where we've dealt with other bacterial isolates that are toxin producers, the way that the phage works, it doesn't seem to produce a toxic effect when the cells are lysed. We need to do all of those trials, and as I said, that will be the next stage, is to do those trials in vivo and have a really good look to see what actually happens. But in my experience, it doesn't work like that. It just doesn't produce a toxic effect. It doesn't produce, doesn't initiate the bacteria to produce a toxin.
Mm-hmm. I would have a question for Adele. Adele, this morning... this morning we heard that to reduce waste in agriculture, in animal production is a key concern, and feed can certainly contribute to that. To which extent do you see, you talked a lot about the feed additives and a lot about feed efficiency, and to which extent do you also replicate these concepts that the salmon industry developed to the other species that you're now working in tropical regions?
I just I don't understand, particularly in other period will be freshwater.
Mm-hmm.
I think we need to look at as a fish waste, as a resource,
Mm-hmm.
not as a waste.
Mm-hmm.
I like the saying of the Chinese, the first product from the cow is the feces, not the milk. Yeah, because they use that to fertilize the garden or whatever. So I think it's, but nevertheless, we are talking about the most efficient animal we ever raised,
Mhm.
is a fish. You know, it's compared to other species, we saw lots of data to that. I know you can do more, but it's, but you need to do that in the most economical way. You know, we know if you increase the energy, you know, you reduce you improve feed efficiency, but in some cases it's not that economic.
Mm-hmm.
We can see that it's even within the same species. We see it is economic in Norway, but not economic in Chile to feed the same species.
Mm-hmm.
For some of the reasons just Pedro said just a few minutes ago. So I'm not sure. I think we should raise more fish, you know, than pigs or other species. But anyway, it's not my say in that case. And I'm very happy that I'm working to raise fish.
Mm-hmm. Any additional questions? Locke, how do you see the phages for EMS?
You are on the spot now.
Just one question, not related to EMS, but just my curiosity about the bacterial resistance to the phage, because we know that bacteria and phage have been there for millions of years. And I think the bacteria should be smart enough, understand how not to be totally eradicated by the phage. So I just my curiosity that, you know, the chance is like 1 in a billion. They should be some cells understand how to avoid the phage.
They certainly do have ways of being able to overcome phage infection. That's why we develop a cocktail, because it's quite difficult for them to overcome several different phage with several different receptors. But even so, if they become resistant, there'll always be a phage that... The job of the phage is to keep up with the mutation of the bacteria. That's what it does in nature. So there'll always be another phage that becomes available. That's why it's such a good technology to use, because it's sustainable. Mother Nature does the job for us. It's up to us to be very clever about how we use it, how we apply it, and how we develop those technologies to stop issues like antibiotic resistance, for example. But even when we have seen a cocktail work, and then the phage becomes not susceptible anymore, it's usually lost its virulence. So some of the stuff that we've done with Vibrio parahemolyticus just recently, it was EMS PCR positive. We challenged it with phage, and we got other bacteria that came up, and we thought, goodness, we've got resistance. They were PCR negative. So even if that happens, and you'd have to ask a molecular biologist about that, because that's way outside my brain.
Mm-hmm.
But for it to change, it needs to really drastically change. The bacteria needs to drastically change.
Okay.
You'll probably understand my accent, but
Finally, she can understand.
I was just sitting here thinking about phage, and I assume that they lost favour when antibiotics came on the scene. But the other thing that occurs to me, you've been talking about infectious agents, and if you go around a lot of the other presentations, and I think I've been in every group this afternoon just to get a real flavour of what's going on, people are talking about gut health.
Yes.
When we talk about gut health, we talk about good bugs and bad bugs. Now, could you develop a series of phages that could actually go in and knock out the bad bugs in the gut and leave the good bugs?
Absolutely. And we've done quite a bit of work on that. So the way that I explain it to people that get really freaked out when I say it's a virus, what is bacteriophage? It's a virus. Oh my God, don't put a virus in my system. It's the same as a probiotic you have good bacteria, you have undesirable bacteria. Phage is the same. You have good viruses and you have undesirable viruses. And we can develop extremely specific phage cocktails in order to reduce unwanted gut microflora. And in Australia, they're talking about the anti-burp, anti-fart phage for cows. I'm not working on that, but to reduce methane.
Well, that concept is completely wrong.
Yeah.
Because cows don't pass it out of their rear end; they actually belch it out through their mouth. So.
Yeah, anti-burp. Yeah, and I'm an aquaculturist, so I don't know what comes out of a cow other than milk.
Okay. Well, the discussion is certainly very interesting, but we need to move on.